Welcome to This Explainer. Okay, today we are looking at what has got to be one of the most phenomenal intersections of ancient history and modern tech that we'll probably see in our lifetimes. We're talking about cutting-edge artificial intelligence and advanced machine learning, literally resurrecting a lost library from the ashes of a volcano. It's basically solving the ultimate archaeological mystery.
So, think about this for a second. How exactly do you read a book that was burned to a crisp 2 millennia ago? I mean, really picture it. These aren't just old dusty books sitting on a shelf. They are literally lumps of carbon. They were blasted by intense volcanic heat, pumice, ash. It turned them into solid charred briquettes. And for centuries, researchers have just stared at these artifacts. They knew they contained the lost thoughts of the ancient world, but they were completely, utterly unable to access them.
The sheer scale of this timeline is honestly staggering. Let's trace it back. 79 AD, Mount Vesuvius erupts, completely burying a luxury Roman villa in Herculaneum, under about 20 meters of hot mud and ash. Now, this villa happened to contain a vast library of papyrus scrolls. Fast forward nearly 17 centuries, they're just sitting there in the dark. Then, 1750 AD, an Italian farmer is digging a well and literally stumbles upon the buried villa, unearthing hundreds of these carbonized scrolls. Then we take a massive modern leap. In 2015, Dr. Brent Seales pioneered a technique called virtual unwrapping, which sets the stage for our massive historic milestone in 2026, an entire scroll being virtually read end to end.
Now, you might be wondering, why did it take so long? Why not just open them? Well, it's because these carbonized scrolls are incredibly, impossibly fragile. Early attempts to physically open them back in the 18th and 19th centuries, absolute tragedy. They essentially destroyed a lot of them. We're talking turning them into dust or shattering them into completely useless fragments. Now sure, a monk did manage to painstakingly unroll a few over a period of decades, but more than 600 of them remained totally unopened and unreadable. Traditional archaeological methods? Yeah, they completely failed here.
To actually overcome this, researchers had to go big, and I mean massive. 300 terabytes. To put that into perspective, that's roughly equivalent to thousands of smartphones filled to the absolute brim with photos. And that's just the data generated from scanning a few of these artifacts. The scrolls had to be taken to major international facilities, specifically the Diamond Light Source in the UK and the European Synchrotron Radiation Facility in France. These are particle accelerators. They use intense, synchrotron-generated X-rays to create these colossal, ultra-high-resolution 3D CT scans. We are talking about the most detailed 3D maps of carbonized artifacts ever produced in human history.
So, all this immense data feeds directly into what's called a virtual unwrapping pipeline. It basically breaks down into 3 logical steps. Step 1, you have the 3D CT scanning we just talked about. Step 2, and this is tricky because a CT scan just yields a giant 3D block of data, you have to actually find and segment the writing surface, so tracing those rolled up, crumpled layers of papyrus buried deep inside the scroll. And finally, step 3, meshing and flattening those layers into a 2D image so it actually looks like a flat page you can read. It's an absolutely incredible feat of geometry and 3D computer vision.
But here's the kicker. Getting a flat image of the papyrus, that's only half the battle. This brings us to the core detective problem of this whole explainer, the ink. See, ancient writers used carbon-based ink, and the papyrus, thanks to the volcano, is now entirely carbonized. So, you are looking for carbon ink on a carbon background.
Right, so to traditional X-rays, that carbon ink is nearly indistinguishable from the burned papyrus. It's the literal definition of searching for a black needle in a black haystack. The scans just see this solid, dense block of carbon. Finding the actual text meant they needed a radically different technological approach.
Enter artificial intelligence. This is where it gets so cool. Researchers trained machine learning models on fragments of the scrolls where the ink was actually visible to the naked eye. By feeding all of this into neural networks, the AI learned to act like a high-tech magnifying glass. Actually, scratch that. It's more like a topographic map. Instead of looking for a change in color, the AI learned to detect subtle physical microtextures, little crackles and structural changes in the papyrus fibers that were caused by the ink just sitting on the surface. It basically learned to infer the presence of invisible ink, finding something our human eyes fundamentally cannot see, hidden deep inside those sealed scanned scrolls.
To truly grasp the precision we're dealing with here, you need to understand what a voxel is. A voxel is basically a 3D pixel. For these scrolls, the scans were operating at a microscopic resolution of 2.4 micrometers.
The AI is scanning through literally billions of these microscopic 3D pixels, looking for the absolute tiniest structural variations that tell us exactly where a pen pressed against the page 2 millennia ago.
Now, what really accelerated this incredible technological leap was the Vesuvius Challenge, launched back in 2023 by Dr. Brent Seals, along with tech leaders like Nat Friedman and Daniel Gross. This was a global open innovation contest. They took the open source software and those massive 3D X-ray datasets and just released them to the public. It wasn't siloed in a closed lab, it was the whole world working on it together. They offered major prize money to crowdsource the absolute brightest minds in AI and computer vision to crack the code.
And that leads us directly to the dramatic mid-2026 milestone. AI successfully read a continuous 1.5 meters, so roughly 5-foot segment of a single scroll, which researchers know as PHRC 1667. I really want you to think about that. An object that was assigned a readability score of absolute 0 back in the 1980s is now yielding a massive, sustained piece of text.
Across that 1.5 meters, researchers recovered over 20 columns of continuous ancient text. The sheer volume of text recovered here is a complete game changer. Imagine finally hearing someone speak clearly after they've only been able to mumble a single letter for decades. Papyrologists and scholars are finally reading full, sustained arguments. They can trace complex philosophical ideas across multiple columns, rather than just playing a guessing game with a few disconnected letters on a tiny archaeological fragment.
Ancient voices speak again. Inside scroll PHPRC 1667.
So, now that the engineers and computer scientists have built these amazing tools, the classicists and historians are finally stepping in. And let's just take a moment to really appreciate the emotional payoff of this. We are looking at words that have been silent since the days of the Roman Empire. From this newly recovered text, we get this incredible line: "We will inquire into something, but we will not grasp it, if in some way we depart from ourselves and from our own nature." It's a profound, really beautiful reflection on human rationality and our innate inclination toward goodness.
The text specifically dives into the Stoic concept of horme, or impulse. Basically, this is the natural drive to act. The author of this scroll warns against excessive impulse. When reason fails to regulate your behavior, leading to harmful passions that divert you from your true goals. It is a really striking piece of ethical philosophy.
Furthermore, it discusses phronesis, or practical wisdom. In a Stoic context, this is considered the highest virtue, the ability to intellectually distinguish good from evil. Because of these specific themes, experts actually believe this scroll might have been written by the highly influential Stoic philosopher Chrysippus. It is the literal return of a lost philosophical voice.
But wait, this epic breakthrough extends even further, pushing right into the core of the ancient Epicurean worldview. AI also uncovered a lost work in a completely different scroll known as PHCRK 139. Right in the final portion of the unwrapped surface, they clearly read the title On Gods, Book 8 by the Epicurean philosopher Philodemus.
Now, what's absolutely fascinating about Philodemus's On Gods is that, until now, historians only knew about Book 1, so this discovery definitively proves it was a massive multi-book series. The newly readable text discusses the concept of providence, the intellect of principle, and the nature of invisible divine entities. It just goes to show the staggering depth of ancient theological knowledge that is now being restored to humanity. We are quite literally rewriting history books in real time. Which brings us to the most exciting thought of all. This is just the beginning. The Vesuvius Challenge is still ongoing. There are more than 600 Herculaneum scrolls sitting in collections around the world, still unopened, still holding their secrets. If AI can reconstruct lost treatises and entirely unknown multi-book series from just 2 of them, what lost ancient voices will AI resurrect next?